so this is also an Ignite talk, but I didn't make the auto advanced thing. So let me introduce myself. I'm Mina. I'm working for Mentor Graphics Egypt. I've been working with them for 6 years. Started as a quality assurance and testing engineer, and then switched to the DevOps or the build and regression infrastructure domain. Okay. So source code changes affect the different aspects of the quality of the product. And we are in an environment that needs to identify good changes so that they can be promoted as an example, and also to identify bad changes so that they can be fixed. This detection process of good and bad changes is getting more and more critical with time. And it should also work in a robust and a timely manner. Why? Because changes accumulate over time, and also accurate detection is needed to avoid making a fuss to your developers. And also you need to run in a reasonable runtime to help get action immediately as needed. So we thought of developing a utility to do this, to automate this process of finding the change possible or responsible for a certain effect in the product's quality. We would name it through this presentation as find change list or find CL. And just as a side hint, change list is our SCM terminology for commit, like Git or something. So this utility could be used to find either good or bad changes, as I mentioned, but it's more common, at least in my workplace, to look for bad changes. So we find other different names for this utility in different organizations, like find bad CL or find culprit, and so on. So let's have an overview of how this utility works, and let's start by the input. A typical set of inputs to a find change list process is the CL's boundaries you want to search in, and how to build your product, what tests do you need to run or analyze, and how to run them. What's the pass-fail criteria that you're going to apply to your tests in each iteration. The logic itself is just a simple loop. It consists of a binary search loop where you start with selecting a change list from a list of provided CLs, and you build your product, run the tests, apply the pass-fail criteria, and then decide on the next CL to try based on the pass-fail criteria. And you continue this process till you converge to a single CL. But let's step back a little bit and think of what do we need to analyze exactly when running these tests. So different groups are interested in different things or aspects or metrics to analyze. But the most common focus areas that we have hit are the functional correctness of things, like things were working or tests were working fine, and then with a new version of your product, things broke. And also performance quality. Did the processing time change? Did the memory or disk space footprint change? And so on. Okay, so up till now things seem to be straightforward, so what do you think is the challenge here? The tricky part is that find change list is now needed at the customer side. And why is this a challenge? Because we can't build our products, Mentor products, at the customer side, and also customers are very hesitant to share their designs with us to bring them in-house. So we started to put together a spec out of our solution as follows. You need to have a generic core logic so that it can be used in different running environments. And you need to have a generic pass-fail criteria or patterns for different types of tests. And also you need to support, from Mentor side, different types of products to build and different platforms and versions of the code to build. And finally, you need to have no dependencies on Mentor scripts or modules and so on. As a high-level overview, this solution will have two main phases or stages. The first is the build and archive phase, which is done at Mentor side. And then the second is the run and analyze phase, which will be run on the customer side. These two stages could be repeated multiple iterations if needed, and I will talk more about this repetition need later. From the implementation view, this will correspond to like two master or core scripts in the implementation, and also will create wrappers for each product group based on need, and I will talk more about wrappers in a minute. Let's have a look at the first part, which I will call the builds packager. The inputs to the packager are very simple and intuitive. The CL's range to build in, number of samples needed to build, because you couldn't build the whole set of CLs in this range. The output location of your package, the build options to use, and any other options related to how do you sync or build or archive your product. From the inside, what the wrapper does, or the packager script does, is to sample this input range and select what CLs I will build, and then it calls another submodule to do the sync and build operation or sync and build step of your product, and then it loops until it archives each build in a subdirectory, and then at the end prepares a package to be delivered to the customer. So what about the wrapper then? The wrapper is just a simple layer over the core script that is specific to each product group, just as a layer of convenience and usability. So it doesn't have any specific functionality other than having an interface of options that is that each group is familiar with. So let's get to some numbers. These are sample statistics for creating a build package of 25 samples before and after compression of builds. So numbers here are for demonstration purposes only, but they can just give you a clue or hint what's the time, disk, or space benefit or cost you will pay if you used compression in your builds in preparing the package step or not. Some final housekeeping hints. First, be careful not to include the failed package builds in your package, just include what's needed. You need to run the logic according to the number of builds in the package, not to the number of builds you expected to be in the package. And last, you need to put an info file with each build to report what this CL sample represents. As we mentioned earlier, we have sampling in place because, for example, if you have like 3,000 changes of code between 2 versions of your delivery or something, and then you put a package sample of 25, so actually the reported CL will be representative for a number of CLs, not just a single CL. So you need to include that info in the package so that you can do final repetitions if you need. So here is the part about repeating if needed. So since you do sampling, you can try to get some final results by going through another iteration of this process to get more closer to the CL you need. Okay. Lastly, I would like to share some opportunities for enhancement that I thought of. We could use archived build from the continuous integration processes instead of doing the builds on our own like each cycle. We could also think of experimenting of zipping each build versus zipping the whole package. This would be a product-specific thing to try. We could also do some smart packaging of our builds. So we could strip the build from unneeded parts for our testing, for example, the documentation or the examples and so on. We could also have a shared place for the common and static dependencies, like any OSS-approved packages that you deliver with your product, like GCC, Python packages, or whatever. You could also think of a way to do an incremental building or patching of your product to put it, to have a way to patch your product with the CL's changes instead of having the full product at each CL. And from the customer side, if you have the disk and resources enough, you can do a brute force attack. Since you have the 25 builds in the package, then why not just unpack them all and run them all and just do the analysis in one step at the end. Okay, so finally, regarding DevOps. So it turned out here that DevOps is not only about Dev and Ops. As we have seen, we have introduced here an area where DevOps extended to a newer ground, which is the field in this case. And on the other side, you need also to consider your real customer's environment while planning the Dev and Ops operations for your product. And the final thing that or advice I want to share is that DevOps is about breaking new grounds and pushing the envelope, and you can cut corners also. Okay, thanks for listening.